Hi, this is Mrs. Myers, and today we're going to do lesson 3.1, lines and angles. There's a few vocabulary words to start with. Our target is to identify relationship between figures in space. So these three vocabulary words are going to be important to those relationships of the figures in space. And to identify angles formed by two lines and a transversal. We're going to learn what that word means as well, this vocabulary word, and relationships that are created with those angles. So first of all, parallel lines are coplanar lines that never intersect. So coplanar, meaning they are in the same plane. Lines, and we could have parallel segments or parallel rays, but whatever we're talking about, they are coplanar, and they never intersect. So if you think of maybe like train tracks, they run right next to each other, parallel, and they never get closer to each other at any point. They just same distance apart forever, and that's called parallel. The symbol for parallel is this. They are like two parallel lines, and they mean parallel. So this would be read, line AE is parallel to line BF. Okay, skew lines. Skew lines are non-coplanar lines that never intersect. So now we're talking about two lines on different planes. They cannot be contained by the same plane that never intersect. You might think of maybe a highway that goes under another highway. So think of like a bridge of a highway coming across here, and the cars going under this highway. These two highways are skew. One is going in one direction, one's going in the other direction, and they don't intersect because they're on different planes. Okay, and parallel planes are when you have two planes that never intersect, or more than two. So we're going to say planes that never intersect. So if you look at this diagram here, they show us in the yellow, they show us these two planes, remember planes go on forever, that are parallel to each other. So if you think of like a box, a cube or whatever, the top and the bottom would be parallel to each other. The front and the back would be parallel to each other. Those are parallel planes. But then when you look at the edges of this box, like this line segment BF and this line segment CG, those are parallel to each other as well. An example of skew line, oh wait a minute, let's go back to parallel. BF would also be parallel to like DH, this back corner. All of these that are green, that are standing straight up, they're all parallel to each other. Skew lines, an example would be two lines, or line segments, right, that are on different planes, so they're going in different directions, but they never intersect. So let's say FG would be skew to, say, AB, because FG is pointing from front to back, and AB is going from left to right, but they're on different planes, so they're never going to intersect each other. Okay, now, right down here where it says use arrows to show AE is parallel to BF and AD is parallel to BC. In a diagram, if we want to show things are parallel, we use little arrows. So AE, that would be this one, is parallel to BF, that would be this one. They have these little arrows like this. That shows, that's a symbol that those lines are parallel. Just like with segments, right? If we had two segments that were congruent, we would put little tick marks like that. That means congruent. Straight tick marks means congruent. But arrows, little arrows, mean that they're parallel. So that would be a way to mark your diagram when things are told to be parallel. Now we're saying that AD is parallel to BC. Well, we already showed these two green lines with one arrow. If we want to show these are parallel, now we're going to use double arrows. Just like with the tick marks, we use double tick marks to show congruence in the same diagram. Here we're going to show double arrows to show parallel in the same diagram. If you wanted to go a little further and say, you know, the next one was parallel, you could use 3 arrows. I'm going to pick one more line here that's parallel. That one's parallel to the other 2 blue lines as well. All right, so that's a lot of notation and symbols. Problem number 1, use the figure below to answer the following questions. Which segments are parallel to line segment AB? I'm going to have you pause the video now and try this on your own, and then come back and check your answers. Okay, so let's talk about the answers here. Which segments are parallel to AB? Well, AB would be parallel to DC, for example, EF, for example, and HG. So we could mark all of those parallel. That's it. Which segments are skewed to CDs? We're talking about skew. They're going to be pointing in a different direction on a different plane, which means they can't be parallel or intersecting. So check your answers here. If we have CD, skewed to CD would be FG, EH, BF, and AE. That's it. Okay? If you have questions on any of the things that you wrote, and you're not sure why what you wrote is incorrect, or maybe you got them all correct, but make sure you're jotting down questions to ask in class, because sometimes these can be a little tricky. What are 2 pairs of parallel planes? So plane I chose ABC, which is the top, is parallel to the bottom, EFG. Remember, we only need 3 letters to name a plane. You might have called it plane ABCD. Sometimes the book uses 4 letters when it's a box like this. And then plane ABF parallel to plane DCG, so the right and the left. You may have chose the front and the back, AD, H, and BCG. What 2 segments are parallel to plane BCFG? So BCFG is the back here. The back, this whole back piece here. That's the plane we're talking about. We need lines that are parallel to that. Well, we can't pick any of the ones that intersect, so we have to pick things that are not intersecting with that plane. So you may choose EH, AE, AD, or DH. Any of those segments that are on the parallel plane will be parallel to the plane. So, in other words, the blue plane here is parallel to this green plane here. So any segment that's in that green plane will be parallel to the blue plane. So you could name AD, DH, HE, or AE. Okay, good. Let's move on. When a line intersects 2 or more lines, the angles formed at the intersection points create special angle pairs. So that's what this next section is about. And this vocab word, transversal, is a line that intersects 2 or more other lines. So it transversal, it goes across. Trans means across. So it goes across two other lines. So in this diagram here, line T goes across line L and M. So T is the transversal. And when the transversal crosses these other lines, essentially it creates 8 angles. So those are numbered here. 1, 2, 3, 4, 5, 6, 7, 8. 8 angles are created by 2 lines cut by a transversal. So those angles that are formed have special names. I want you to think about this diagram, and we're going to do an activity about this diagram in class one day. But think about the diagram. There are 2 lines. Between the 2 lines you see here is yellow. That's the interior. Interior is like between the 2 lines. Exterior would be on the outside of the 2 lines. So all the points above and all the points below. So the first term here is alternate interior angles. So we're talking about any angles that are on the interior would be called interior angles. These particular interior angles are called alternate interior angles. And they're called alternate interior angles because they are on alternating sides of the transversal, different sides of the transversal. Alternate interior. So if you look at the diagram, angle 4 is an interior angle. 3, 5, and 6 are all the other interior angles. The alternate interior angle to angle 4 is considered angle 6. So angle 4 and angle 6. Also in the diagram, angle 3 and angle 5. So alternate interior angles are on different sides of the transversal. They're on the interior of the lines. And they do not have the same vertex. Okay? So let's look at the next one. Same side interior angles. Okay, we're still on the interior, so we're still talking about angles 4, 3, 5, and 6. Let's take angle 4 again. Well, now what angle would be on the same side of the transversal? Same side interior angles. 2 angles that are on the same side of the transversal. So angle 5 and angle 4 would be same side interior angles. They're both on the interior of the lines. They're on the same side of the transversal. And that makes them same side interior angles. What would be the other pair of interior angles? Angle 3 and angle 6. All right, corresponding angles. Corresponding angles are going to be angles that are on the same side of the transversal. One's on the interior, one's on the exterior. I know this one doesn't really have a very descriptive name. We're not calling them same side angles at all, but they're on the same side of the transversal. One is on the interior, and one is on the exterior. So in this case, angle 1 and angle 5. Angle 2 and angle 6. You can see they're color-coded over here. Angle 4 and angle 8 and angle 3 and angle 7. Another way to think about it, if you think about these angles at the top. Oh, that's not what I meant to do. I wanted the highlighter. There we go. These angles at the top, those 4 angles go together because they all have the same vertex. And then the angles at the bottom, these 4 angles kind of go together because they have the same vertex. When you have corresponding angles, they're kind of like in the same position. One from the yellow, one from the blue. In other words, if I take angle 2, we're talking about like the upper right-hand corner of the yellow angles. And what's at the upper right-hand corner of the blue angles? Angle 6. So it's kind of like they're in the same position, top and bottom, yellow and blue. So if we take angle 1, that's upper left. Angle 5 is also upper left. They're corresponding. They have the same corresponding position in the 2 sets of angles. Okay, alternate exterior angles. They're going to be on alternating sides of the transversal, so different sides. And now exterior. They're both going to be on the exterior of the lines. So let's look at our diagram. If we have exterior angles, we're only talking now about angles 1, 2, 8, and 7. Those are the exterior angles. So alternate exterior angles are going to be on different sides of the transversal. So angle 1 on a different side of the transversal would be angle 7. Not going to be angle 2 because of this last criteria, which we need to put here. Do not have the same vertex. If you think again about the yellow and blue, the way I had this highlighted before, in every single one of these terms that I just explained, every single one of them has one from yellow and one from blue. One from yellow and one from blue. If we go back up here, right? 4 and 6. 6 is from blue, but 4 is from yellow. Same side interior angles. 6 is from blue, but 3 is from yellow. 5 is from blue, 4 is from yellow. Right? So in every single one of these cases, one's from the top group of angles and one's from the bottom group of angles. Okay, so our alternate exterior angles here are going to be angle 1 and angle 7, and angle 2 and angle 8. Okay, use the figure below to answer the following questions. Name a pair of angles that are alternate interior angles. I am going to let you pause the video and try this on your own. You can turn me back on when you want to check your answers, and then I'll take any questions in class tomorrow. Okay, so you can check your answers here. I'm going to let you do that on your own. So pause the video, check your answers. I'm going to scroll so you can pause the video again and check more answers. Be right there for a little bit. And then you're going to want to check your answers down here. One thing I wanted to just point out was this explanation of who's correct, Dan or Mary. Dan is correct because we could draw this plane that kind of goes diagonally through this this cube or box. Okay, so there's a plane that can go diagonally through. So therefore they are coplanar. I'm sorry. So they are parallel because there's a plane that can contain both of them. Okay, I'll see you soon.